So, welcome. My name is Peter Carlson, and I will be presenting the Center for Business Solutions, which is next door. And I'm going to explain a little about how the technology works that we work with and how it can benefit the university here, and the students, and the teachers, and the researchers, etc., etc. We're kind of anonymous at this university. Like maybe half the people working here does understand what we're doing. So hopefully this is going to make some ripples in the water as well. So people talk about what kind of resources they're actually present here right now and what it can be used for, not only in educational purposes of using ERP systems. So we are in a collaboration with Sante Academy, which is kind of a board with other universities that has the same agenda of educating students in how to use business systems when they come out in the real world and start working with economics. Because this is not a usual thing to be educated in at the university. So we are providing the service, other universities are providing lectures, and we're trying to have a collaboration with the vendors as well, which provides us with real data that we can use in our student courses. Anonymous data, but still real. So that's just some of the reasons. And these are the bullet points we're supposed to go through. We have some virtualization, some mobility, the resources, where it comes from, what kind of universities we're supporting right now, what kind of environments are we doing, and what kind of tools we have from our sponsors, and how big calculations comes into mind. So I'm going to run an access video here in the background, just for some immersion, to show you how easy it is and how complex it is at the same time. So what I'm showing here is what the connection flow is going and what kind of virtual server I'm using and what's on the virtual server and what application you're supposed to use. So for instance, if I'm one of these guys that wanted to try out Aggresso, which is an ERP system, you access it through a remote session, really basic, and we sponsor the data and software we get from our vendors. Everybody starts using the real thing as a student, or a researcher, or a teacher, doesn't matter. And this is the thread it takes through physical computers and to a virtual computer. And come on, animate. Bring it with you. It doesn't matter where you are, you can still use it on your cell phone, which is really tedious, by the way, because it's really, really small, but you can still zoom and everything, and you can use the software wherever you're standing. This was a big thing back in the days, because mobility, nobody understood, right? Is it a laptop? Is it a thin client? Is it a rich client, etc.? It doesn't matter anymore. It doesn't matter what kind of platform you're using. It works on everything right now. So the mobility is the key with what we can provide. So you can sit wherever you want, even if you are on a crappy airplane with a so-so Wi-Fi connection, you can still do your coursework with a workload of a sort of a mainframe support and still work and have a support. So the first picture there, I'm actually using a PDA back like 5 or 6 years ago when I started working, and it worked then just as good as it works now. The only difference was the connection, right? Using GPRS or a GSM connection or a local Wi-Fi or a TP cable, doesn't matter. It was still the same back then as it is now, but it's faster now. And now it doesn't even depend on what kind of platform you're using, which is really cool. Oh, you can package it as well. So when you're finished, let's say you have a virtual environment which you have been researching on or had your students on for like several years, and you say like, I'm fine with this now. I want to archive this and take a look at this some other day, or use it in a research. Package it, put it on a USB. It works. So we have a lot of resources, as you can imagine. Most of it is just local hardware, which is configured untraditionally. But it's mobile and it works and it's sponsored at the same time. And we're supporting a lot of universities at the same time because they need our resources, because we have the knowledge from years back how to even start. And I can tell you how it started with the first virtual environment. And it was on Virtual Server 2005, which was virtualized as well on an IBM 400 series mainframe. And those babies are expensive and really heavy. It was like a 3-ton ratio. We had to check the floors at that university so it wouldn't break through. Those are really heavy machines for doing virtualization. But today, you buy a rack server and do basically the same thing. You can still virtualize and have big virtualized clusters. So we build environments. This is what we do. We take a connection, we port it to a web interface or just a traditional remote interface. We made it to a mobility phase to make it work. And this is not traditional at all, because most of our vendors, sponsors, hasn't even tried that on their own software before we did, but it worked. So we get some orders from other universities that we need this kind of an ERP system, this much students, we need this kind of educational information. And we said, fine, we build it, we virtualize it, and we cluster it. So it can be used over and over and over again. And each virtualized segment takes about 100 user workloads at the same time. That's pretty much just to have a desktop interface and the GUI, start working with like modeling or import, export Excel documents, using Power Pivot, for instance, if you know what that is. It's pretty heavy. One user times 100. So we have done this since 2008, and we're pretty good at it. That thing over there, you probably missed it. That's the packaged version I'm talking about. You can actually package this and you can put it on any platform, basically. So today we can use it on Solaris, OS X, Windows, Linux, all the other Linux names, doesn't matter. Even on NetBSD, if it's just in text. It's still packageable, no problem. Movable, no problem. Exportable, no problem. You can go and do this back and forth. And if we do this locally with somebody on a computer, if you have a research work or whatever, and we build a virtual environment on that, if you're fine with it and you want to cluster it, we export from your client and put it in a server. And the server equals cloud, and then it's clustered. And then you put in more force in it, because you probably need more force, because you're fine with what you have here, and you want to make it faster and more doable. And then you see other purposes, like, wait, they have a lot of sponsors here with analyzing tools I can probably use on my research data. Why not connect those as well? Because they're locally in the same environment. So there's a lot of things to try out here. These are the tools. I'm calling it tools, or Legos. So these are the basic suite we're using right now. We have additional as well, but they're not worth mentioning right now. But most of these are high-end names you probably bumped into recently or before. And like Microsoft or ClickSense, you have a lot of extractability and modeling you can do with your data. So don't get just stuck in using your kind of software and your platform which you're used to without checking out what the vendors can provide for you to probably make something more easier. You with me? QuickSense is a good example, for instance, because you can, if you dump a lot of data into Excel documents, you can put it in diagrams, and in real time, using your PDA, you can rotate and check out diagrams at the same time it updates on the server. So you see the same thing on the PDA and the server. So if you have a quick presentation you need to do on your research work or whatever, throw it up there, start twisting it around and see like this diagram is really big, see? Could be good for you, I don't know. So what kind of big calculations comes into this? And it is the ability to build a platform for your project. You can connect the sponsor tools as I mentioned. You can cluster it on several servers for one purpose. So let's say you have a big calculation you need to do, but you can make it on several computers at the same time. Let's say you just add this when it's finished, instead of doing all the workload on one server, and you have to wait for like 24 hours before it's finished. Why not divide it? And then check it up on your PDA when it's finished. And connect to other databases. As I said before, we have real data as well. Mostly it's anonymous because they can just put up real awesome data from real companies who made mistakes. But it's still there. And you can connect that data to your data. If you're working on like SQL or Oracle, and you have databases which you're modeling, why not connect it to another database and cross-check the information if possible? Make some dumps, make some examples, analyze it, because it's there. And we can ask for more if it's related to a research. Which comes to the next part, questions. Any questions? Or was this like 100% accurate for you?
When you say databases, what exactly?
Sorry?
When you say databases, we can combine databases.
Yeah, we can use one of the sponsor software, for instance, and connect several databases and use their ERP system or business intelligence tool to analyze the data.
So, for example, the university has access to Orbis. I don't know if you know Orbis database or DataStream or CompuStat.
Yeah.
Can we connect all these databases to these tools, or what?
It depends on how your project works. So, if we build a server for this, a virtual environment, we can probably connect all of these things without a problem, because we're on a local network. Everybody uses SUNET, and we have the analyzing tools as well, so we don't have to make the software to make it work. So probably yes, if you connect a lot of things. I understand where you're talking about threading like additional databases from other sources and trying to have a center core.
Yes.
It's possible, yes. I would start small first to see if it works and if the information is viable to provide to yourself or others as well, or it's just nonsense because it's too much information as well. But there are tools to analyze this data, and we can probably provide most of it.
Yes.
Any other questions?
Can you play some Docker images there?
Some.
Can I log in and just run a Docker image?
A Docker image?
No, so it's like encapsulated environment.
Nothing I've ever tried before, but if you show me, you can probably do, yeah.
Because this way I can just run a different program in a sandbox environment on your server.
You mean initiating a source in another location and then returning to it later on, or?
No, so for instance, you have a list of software that's already pre-installed, right?
Mm.
But let's say I want to use, back of the battery using R.
Yep.
I can pull a Docker image of R and then run it. And can I run it? Or can
if you install the software on the virtual environment, yeah.
Okay.
But let's say you have a project.
Yeah.
We make a virtual environment for you. You install all the software you need
Okay.
and what you want to provide on the virtual environment, and then we add stuff that you need to this environment. The
Okay.
environment is yours. You can do whatever you want with it, basically.
And this is sandbox.
Sorry?
This is sandbox. Nobody.
Well,
does
it's isolated environments.
Okay.
So there are unique ports. Everything is remote,
Mhm.
but it's behind firewalls and dedicated gateways, which just provided for you. So every instance we create would just be a private connection. You will not have anything else going through there. In case of you're not installing malicious software yourself, of course.
And then, what do I see? How many cores? How much
Well,
memory?
it depends, but we at the basics we have like 16 cores on one server and 64 gigs of RAM as a base, and then you can cluster it to 2 or 3 servers as well. Right now we can basically run 10 of those servers at the same time without having too much workload for the other universities. And you have to have in mind these are servers on Blade servers, which uses storage area networks as well. So it's just the data flow there between hard drives is really fast. So the workload isn't always on the CPU and the RAM. It's always the connection flow as well. How fast are you calculating or compiling the information through the optics that goes through the storage area network? So sometimes you don't even need 64 cores, if possible. You can just
And the
have
cores
50%
are
of it.
probably Intel Xeons, right?
Sorry?
The cores are probably Intel Xeons.
Well, everything is ProLiant servers here, and everything is Intel, yeah. The latest one is several i7 cores, so, which with a local sound as well, so it works even faster.
So how do I get in?
We'll discuss that later. Any other technical questions?
Yeah, it's not so clear to me what. So what I usually do is that I use clusters, and then you either compile the work yourself and send it to the cluster and run it.
Yep.
Is that the same idea here, or?
It's the same idea, but you have your virtual environment to run into. You have your workspace always online, sort of. So it doesn't matter if you're using your computer or another computer, and you can have your workload constantly working, and you can just tap back and forth wherever you are. You don't always have to return to your work area and check, is everything working? You see? So you can just flip out your phone or whatever and say, oh, it's finished, now I can return.
But it doesn't work with batch queues or something like that? Or?
That's what I don't know about right now, but we can probably make it work.
Well, of course, it's nicer for anybody to have no batch queues at all, but then you have a lot of people just maybe using 16 cores at the same time, or maybe even a 64 cores and not doing
But that's the
anything.
thing, when you have a virtual environment for you,
Yeah,
it's just yours.
yes.
There's nobody else on the queue, it's yours. So you have an idle server waiting for you to do something.
Yeah, that's true, but that might be also a problem, right? Isn't it? Or because then I might work all day with these 64 cores,
Yep.
and maybe I'm using at most 5% of one of them. And
will
then
be
at the
no
end of the day, maybe I start to do some calculations, and all the time, all the other cores have been idle all day.
But that's for me to have, that's my problem as an administrator of the cluster. So I have all the configurations finished in front of me, and it says to me like, that workload is like 5%. They just okay that, and the workload goes to some other server at the meantime. So I can dedicate like with rules and dedicate server loads to specific user groups or adjust the user. Everything is just compilable, it's no problem.
There is a finite number of those cores. So
Sorry?
there is a finite number of those cores, right?
Yeah.
So how does the queue work?
Well,
If you have more demand than supply.
we haven't bumped into any of those kind of problems before because we have the workload right now. But this is a learning process as well. Because if we start bumping into stuff, then we know how much more hardware we're supposed to buy in. Or outsource. Because we're still in the Gothenburg University, and their architecture we can borrow if something goes haywire. But as for now, with those amount of universities you saw before, and you can imagine the user groups, about 100 people each class, accessing our servers, and nothing happens. So right now it's not a problem, right?
But it works now much more like a normal computer. I can just expect that if I have 64 cores, then I can do exactly the same thing as what I do on my computer,
Well,
but now
if
on
you-
64 instead of 4.
If you're really like obsessed of using Ubuntu or those kind of platforms,
Yes.
you're going to be restricted, of course, because you still need the Windows interface. But we can virtualize within the virtualization as well. I've done this like 100 years before. You can have like your Ubuntu interface if you're really dedicated to this, and extract and do whatever. Like, what is it? It's a better word for this. Coherently? Like it's gonna be I can't find the word for it. Transparent. You can make it as a transparent application. So what you do on the Ubuntu saves locally on the Windows server, and you can connect disks between them, whatever you need to do. So the only restriction here is actually to build the environment to make it fit you and your requirements. But in the base, it's a finished Windows Enterprise server, which you just log into and start installing your software what you need. Do you need to virtualize the virtualization? Go ahead. It's going to affect your course a bit, but it works.
And the idea is for this to be meant as a tool used in courses or also for research.
Well, we're hoping to use this for everything. But we have to start somewhere. So this presentation is about showing you there's some possibilities here, and we'll start making some demos and see if it works for everybody. And then there's it flows, so to speak. Anything else? Great.